All right, let's check some understanding on 3.2a. What we got is here some data were collected on the weight of male white laboratory rats. Ooh, for the first 25 weeks after its birth. The scatter of Y equals weight in grams and X times since birth in weeks shows a fairly strong positive linear relationship. Okay. The regression equation is this right here. So if we just want to specify this Y value is referring to the predicted weight in grams of the rats. All right, predicted weight. And this right here is the time since birth in weeks. All right, time, all right, since birth. All right, and so that's in weeks. And this right here is in grams. Okay, I'm just doing that. It doesn't ask you, but these are predicted. Okay, so remember, look at the y hat. So we want to interpret the slope of the regression line. So the slope of the regression line essentially states that, so for every additional week since birth, the predicted weight will, now this is where we look at our slope. So 40 is our slope. The predicted weight will increase. Now it's increasing because it's a positive slope. Increase 40 grams. So for every additional week since birth, the predicted weight, I should say of the rat, all right, of the rat will increase 40 grams. Okay, so that's what we have. So for every additional week, the weight goes up, all right, increase of that because that's by 40 grams. That's a slope. And that's how we would do it. Okay, so now, does the value of y-intercept have any meaning in this context? And so, if so, interpret the y-intercept. So, right here, if we plugged in x equaling 0, okay, so essentially that would be when they're born. Okay, so that would be, and what would give me is a predicted birth weight. So yes, all right, that would be the predicted birth weight of the rats. All right, which is 100 grams. Okay, because that's our y-intercept right there. When we look at that, that's our y-intercept. Okay, and so we have that right there. So yes, so when we put that in there, we get a y value of a weight, all right, of 100, all right, grams. So that would be 0 weeks after that. So yeah, so that's what we have there. Now, finally, the predicted weight at 16 weeks. All right, now we're not extrapolating here because this is for the first 25 weeks after birth. All right, so that's within from 0 to 25. So that's not extrapolation, but what is our predicted value? All right, well, we're going to figure this out by just simply plugging in 16 into there. So we have 40 times 16. And what do we get for this value? If we take our calculator, all right, we can take 40 times 16, all right, plus 100, boom, 740, all right, 740 grams. All right, that's a big rat. All right, well, in any case, that's how much the rat would weigh. Whether it's a good prediction or a bad prediction, that's what we have. Now, calculate and interpret the residual if the rat weight is 70 grams after 16 weeks. So we want to calculate the residual here. Okay, we're going to calculate the residual. And so when we're calculating the residual, we're going to have, remember, residuals are A minus P, so the actual weight, which is 700, all right, minus our predicted weight of 740. So that would give us a residual, all right, of negative 40. So what do we know? well, we know that the predicted all right, weight at 16 weeks is, all right, 40 grams, all right, and since it's going to be more than 40 grams or 40 grams more than the actual weight at 16 weeks. And that's what we know with the 40, because the 40 means, since it's a negative, that means the predicted weight is going to be greater than the actual, so it's going to be 40 grams more than the actual weight at 16 weeks. If you want to say this, you could also say that the actual weight is less than 40 grams of the predicted value. In any case, that's what our residual is talking about. Okay, and finally, should you use a line to predict the rat's weight at 2 years old? Use the equation to make a prediction and discuss your confidence in the result. There are 454 grams in a pound. All right, let's just check this out. Well, 2 years old. All right, well, how many weeks is that? All right, first 25 weeks of its birth. Well, if it's 2 years old, there is 52 weeks in a year. So if you multiply that by 2, we're putting in 104 into this equation. So our predicted would be 100 plus 40 times 104. Okay. So 104, if I clear this, 104, all right, times 40. Okay. And then we're going to plus that to 100. All right. 4,260. All right. So 4,260 grams. That's going to be, wow. And we divide that by 454. All right. Divided by 454. All right. That's a 9-pound rat. That's like a small dog. Oh, wow. All right. So 9 pounds using this equation to predict it. Should use the line. No. Okay. No. 2 years is outside of the 20-week or 25-week data sets. And the prediction would be extrapolation, and not very valid. As if we continue on, the predicted value predicted weight of the rat would be around 9 pounds. 9 pounds. Oops. Which is a little big. Be around 9 pounds. All right, 9 pounds. I'm just going to add this. That's a big rat. That would be a big rat. Okay. Wow. All right. So we wouldn't use that. That would be extrapolation. That's what we're talking about. So we won't use that around our data set, our explanatory variables. And since we're going from 0 to 25, 109 is definitely outside of that. And so we would not want to use that data. All right. Well, we went through checking understanding of how to interpret our linear regression line, how to find the slope, how to find out predicted values, what the Y-intercept is, and also residuals and extrapolation. I hope this helps you out with the rest of your problems, and yeah, good luck and God bless.